Explain like I'm 5. Why is the factorial of 0 equal to 1? Wouldn't this also mean that 1 0? Why is this true? A way to think about it is how many ways can you arrange 0 things? One way. How many ways can you arrange one thing? One way. There is an excellent video by Eddie Wu on YouTube. I don't know if I can link it, but I highly recommend you go watch it. However, the proof basically boils down to 1 1, 2 2, 3 6, 4 24. Find the pattern. To get from 4 to 3, divide by 4. From 3 to 2, divide by 3. From 2 to 1, divide by 2. What will be the next answer? Divide it by 1. 1. It fits the pattern in our made-up language of mathematics. Because 1 is the neutral element of multiplication. Which number do you need to add to something so that it's like not adding anything? That's 0. Which number do you need to multiply with something do that it's like not multiplying anything? That's 1. 0 represents no multiplying anything. 2 is what you get when you multiply 1 by 2. 1 is what you get when you multiply 1. 0 is what you get when you multiply. So 0 is what you get when you're multiplying. But you're not putting anything in. That's called the empty product. The empty product is usually defined as 1. Because that's the multiplicative identity, same as how the empty sum is 0. The additive identity. 1 is nothing in the context of multiplication. Not 0. Because nn1xn. For example, 32x3 or 128,127 by 128 . That holds for all n greater than 1. If you also apply it to 1, it would imply that 1. No reason to break the pattern. The real answer is because we say so. We define the factorial however we want. The other answers are justifications as to why defining 1 makes sense. We could say that 0 is simply not defined as our 1 and 0.5. For instance. However, it would mean we would have to deal with many special cases. We would have to do things like fn. If n 0 and otherwise. It is way more useful to just define 1 so the equations look cleaner. Edit changed convenient to useful. As UPJ's suggestion. Everyone here's talking about combinatorics. Which is a useful way to visualize it intuitively. But the real, mathematically rigorous reason has to do with the mathematical definition of the factorial. Which doesn't have to do with combinations, though that's one useful application. Definitionally, a factorial is a product of successive terms. The key is what is the empty product? What is Yule product of the integers in the empty set? The answer is 1. The empty product is 1. Because the multiplicative identity is 1. Just like the empty sum is 0. Because the additive identity is 0. That's really just a convention that greatly simplifies most formulas. It also makes sense in terms of combinatorics, as there's only one way to arrange nothing. N is the number of possible permutations of n distinct items. That is without repetitions. Factorial is typically used when figuring out combinations. X tells you how many ways there are to arrange X objects. There are 0 or 1 way to arrange 0 objects. There are also people who define factorial recursively for reasons I won't get into here. So nn1 times n. If 0 wasn't 1, this wouldn't work anymore. I've been criticized for this view before. But I believe that 1 because it's mathematically convenient for it to do so. Rather than because it really does for anything real. Because you think factorial as a multiplication while it is actually a division. nn1 n1. For n0. 1 1 1. A lot of people trying to give answers that prove something. The reason 1 is literally because we said so. It's not like factorials exist as an entity outside of mathematics. Mathematics is not physics. Factorials are not something that mathematics tried to explain. It's something that we created entirely. And in the process of doing so, we define it in a way that's useful for our purposes. Proofs in mathematics only prove things about mathematics. As seen in Terminator, there's no fate but what we make for ourselves. To go from 10 to 9, you divide by 10 by 10. 3628800. 10. 3628880. To go from 9 to 8, you divide 9 by 9. 3628880. 9. 40320. To go from 3 to 2, you divide 3 by 3632. To go from 2 to 1, you divide 2 by 2. 221. To go from 1 to 0, you divide 1 by 1. 111. An empty sum is 0. Because 0 is the identity of addition, for example, you can imagine ABC instead as 0 ABC. Then if you got rid of subtracted a, b, and c, you are left with 0. An empty product is 1. Because 1 is the identity of multiplication, for example, you can imagine ABC instead as 1 ABC. Then if you got rid of divided by a, b, and c, you are left with 1. 0 is an example of an empty product. So it's 1. In the same way, a number to the power of 0 can be thought of as an empty product. So that's also 1. The reason is actually pretty simple if you think of the pattern factorials follow. 4 3 times 4. 3 2 times 3. 2 1 times 2. What's the next equation? 1 0 times 1. So yeah, 0 does in fact equal 1. Both are equal to 1. Because it's useful. If you start by defining factorial as the product from I1 to n of I, and only defining it on positive integers, then you can extend it any way you'd like. If you want to define 0 0, then that's fine. But it turns out that it's useful for making combinatorics equations work. And also the analytic continuation, the gamma function must have O1. There's no analytic continuation if 0 0. The definition of factorial is the product of an integer and all the integers below it. Outside this definition is the definition that 0 factorial is to 1. Just accept it as a definition. I have seen attempts of proofs, but to me they always fell short. For the first point is that anything multiplied by 0 0, see what I did there? For addition, adding 0 keeps the answer the same. For multiplication, multiplying by 1 keeps the answer the same. Factorial has to do with multiplying, so doing nothing should be multiplying by 1. Many will have given great explanations already. So I'll just say this. It's a pattern that involves multiplication. The nothing of multiplication is 1. We could choose 0. But then any further terms would also be 0. Which isn't much of a pattern. We could choose a number other than 1. But any choice would be rather arbitrary. Why should this pattern that we are exploring start with 3 or 57? We'd just end up carrying this extra factor through the pattern. Which would be odd. A common thing in math is called recurrence relation. Basically it tells you when you have a series or a pattern how to get the next thing from the thing that came before. For the factorial function, the recurrence relation looks like this. NBSP. NNN1. NBSP. So for example, if you know that 4 is 24, then you know 5, 5, 4, 5, 2, 4, 1, 2, 0. NBSP. So we know 1, 1. So then we also know 1, 1, 0, which would make 0, 1. A pretty decent way to think about it is 1, 1 by 0. And we know 1, 1. So the only way you can have 1 by 0, 1 is if 0, 1. It isn't mathematically rigorous, but it's a way to think about it.